Moles. This is going to be our 5th unit. And we're not talking about these cute, cuddly moles like this little guy right here, who I'm sure we would all love to have as a pet. He just looks so pleasant. We are talking about the unit of measurement with moles. Now, we mentioned moles at the very beginning of the year when we talked about scientific notation and the value of scientific notation, because a mole is such a huge number, and so we wanted to be able to shorten it. And so one mole is equal to 6.02 times 10 to the 23rd, there we go, to the 23rd particles. So anytime you have 1 mole of something, that means you have 6.02 times 10 to the 23rd of that thing. And if you remember, I think we looked it up in one class, you would move this decimal 23 times this way, you'd have 21 additional zeros, so that's 602 decillion of any item that you have. And so if we had 1 mole of baseballs, we'd have 6.02 times 10 to the 23rd baseballs. That's 602 decillion baseballs. That's an absurdly huge number of baseballs. If we had 1 mole of pencils, we'd have 6.02 times 10 to the 23rd pencils. Again, an absurdly huge number of pencils. So you get my drift here. What we're talking about, 6.02 times 10 to the 23rd is a huge number, and that's why we use a mole. We use a mole because nearly everything in the entire world has tons and tons and tons of particles within it. So if we're talking even about a molecule is made up of billions and billions and billions of tiny particles. Therefore, it's easier to say, instead of 974 decillion particles, it's easier to just say we have 1.4 moles of whatever particle we're dealing with. So we use moles just because so many different small items, like molecules and atoms, involve so many particles. So we use a mole because it allows us, kind of like scientific notation allows us, it allows us to have a different unit of measurement to measure a larger quantity of items. So 1 mole, 6.02 times 10 to the 23 particles. Now, on the paper you picked up on your way in, where we're kind of guessing how big a mole is, that first section where it's the fun facts, I'd like you to guess on those. Like, now that you know how big a mole is, it's 6.02 times 10 to the 23rd particles, guess on each one of those, and then I'll show you the stats later on in class to see if your guesses were close to correct. Now, with moles, we have to be able to make some conversions. So we're going to start off with some pretty straightforward and simple conversions. And I'm going to do a few examples on here, and then you can go on to the examples on the paper you picked up on your way in. So my example will be similar to your first example that talks about pennies. I'm going to use quarters. So if I had 1 mole of quarters, if somebody offered you 1 mole of quarters, would you rather have 1 mole of quarters or 1 billion dollars? Make the choice right now. Would you rather have 1 mole of quarters or $1 billion? Okay, let's see which one will give you more money. See if you made the right choice. If I had 1 mole of quarters, that means I have 6.02 times 10 to the 23rd quarters, right? Because it's always 6.02 times 10 to the 23rd. Now I want to compare that to $1 billion. So how can I determine how many dollars are in this? Well, easy. I have 1 mole of quarters, and I have, in $1, I have 4 quarters, right? 4 quarters for every dollar. So if I have 6.02 times 10 to the 23rd quarters, and every four of those quarters equals $1, all I need to do to figure out how many dollars I have is 6.02 times 10 to the 23rd, and I need to divide that by 4, and that's going to tell me how many dollars I have. And it turns out, when you multiply that out, you end up with an astounding 1.505 times 10 to the 23rd dollars. So that would mean we're moving this 2, 3, etc., moving it 23 times. So 1.505 times 10 to the 23rd is way more money than $1 billion. So 1 mole of quarters is a huge amount of money. 1.505 times 10 to the 23rd. Written regularly, that would be 1.505. That'd be moving it what? 1, 2, 3 times. So then I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 zeros. So that is a huge quantity of money. So hopefully you chose the mole of quarters over the $1 billion. Another example we could do, if we had one mole of baseballs. We have 1 mole of baseballs, so that's 6.02 times 10 to the 23rd baseballs. Okay, that's what I've got so far, 6.02 times 10 to the 23rd baseballs. And I have to put them all into bags. One bag of baseballs holds, one baseball bag or one ball bag holds 30 baseballs. The question, how many bags do I need to hold my 1 mole of baseballs? That's an excellent question, right? Because we got to know how many ball bags we need to hold the number of baseballs that we have. That way we can transport them around. So I have 1 mole of baseballs, which is 6.02 times 10 to the 23rd baseballs. 1 ball bag holds 30 baseballs. How do I figure out how many bags I need? Well, I do 6.02 times 10 to the 23rd, and I divide that by 30. Why do I divide that by 30? Because that's how much 1 bag can hold. So if I divide that by 30, it's going to tell us how many bags we need to hold this number of baseballs. And if you divide that out, your answer is going to be 2.00 times 10 to the 23rd. So we'd go 1, 2, and then have to add 21 more zeros. And so in the end, we would need 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That is how many ball bags we would need to hold our 1 mole of baseball. So you can see how huge 1 mole is. Now what I want you to do, go on and finish that paper you picked up on your way in. It's going to give you a good feel for how many or how large a mole really is. And again, we're not talking about the cute cuddly mole, although if you want extra credit, you could get me a pet mole. That'd be awesome. Just kidding. Don't bring a mole to school. That would be dangerous. Have a great day. Enjoy learning about moles. Fare thee well.